Okay, so when we start doing the rational functions, because they're fractions and it's polynomial over polynomial, I cannot have a zero in the denominator. So that yields vertical and horizontal asymptotes. Now, I kind of made up how this works because it's like I learned a long time ago that if you have a method to do something, it's easier to learn something. So I kind of made this up. So this is, I put vertical asymptote here, VA. I put horizontal asymptote here, HA. I put my X-intercept here and my Y-intercept. Okay? So basically, you're going to graph these, and with algebra, you're going to be able to justify how the graph should look. And in fact, you could kind of sketch it without looking at the graph first, but I don't care if you graph it and make sure, yeah, that works, okay? The one thing I do want to remind you is the horizontal asymptote, I'm putting a star there because there's 3 ways to find it. You have to memorize them bigger in your notes. So you need to know that. This will help you so much that if you have these memorized for the horizontal asymptote, how to find it, when we do limits, it's going to be a lot easier if you know these by heart, okay? So let's start with the vertical asymptote. In order to find the vertical asymptote, we take our denominator and put it equal to 0 because that's holes in my graph, so that helps me find the vertical asymptote. Does every single rational function have one? Absolutely not. But we're going to make sure we check it and make sure there is one. Horizontal asymptote, that's when you take your numerator or your denominator and you're looking for the 3 rules. There's 3 rules that you need to memorize that will tell you what that is. Okay? The X-intercept is a number 0, so when we put 0 in for y, we can find where it crosses the x-axis. And the Y-intercept is 0, a number, so if I put 0 in for x, I can find where it crosses the y-axis. Again, you can check all this on your graph, but now we're making sure that we know how to do this algebraically. This is the exact order that I do this as well. I always do the vertical asymptote first, and then I do the horizontal asymptote next, and X-intercept and Y-intercept. You can mix them up, but it really helps to understand if you do this first, all right? So let's do the vertical asymptote. I'm going to take the denominator, put it equal to 0. Now, you can move the 9 over and take the square root, but you know what always happens is I have somebody forget it's plus minus. So I'm actually going to factor this. Do my big T. So I have x plus 3 equals 0. This is the work I want you to show. X equals negative 3. X equals 2. An asymptote is a line. It's an actual line. So I want you to write it as x equals negative 3. X equals 3. So those are vertical asymptotes that go up and down. And as we do the sketch here, we can figure out how this graph looks. That means my graph doesn't really exist there, but I have over the years learned that I always tell everybody, it's like a bench. You get really close, but you don't touch it. However, there has been times when functions will cross it real quick, so you get a little zap, but then, but it actually approaches it, but it doesn't really touch it. Yeah. It kind of reminds me of my neighbor, their dog. They had gotten one of those electric fences, so he was all happy about it until one day his dog got across. So he took the dog collar off. The dog wouldn't get zapped, but he had it in his hand. So he's walking the dog back. He got shocked going back over it. So yeah, remember that. This is kind of what an asymptote is, a line that you kind of don't see, but you don't cross it. But you do once in a while, okay? Horizontal asymptote, you take the 3 rules. You take your numerator over your denominator. What's that mean? When you take the power, so basically you're just going to write this. And I see the power in my numerator is smaller than the power of the denominator. That's one of the 3 rules. What does that tell you? If you don't know, look in your notes, because I did this in the notes. This was a video you're supposed to watch for today. What does it say if the power in the denominator is smaller, because it's a 1, versus the power in the numerator is smaller than the power of the denominator? Yes, Mike? Y equals 0, because if your power is smaller in the top than it is the bottom, then you are going to have a horizontal asymptote. You need to have that memorized. That's one of the rules, okay? Here, if I want to find the X-intercept, so I'm going to erase this here. The X-intercept is a number 0. So when am I putting in for 0? Y. So there's my formula. I say 0 equals x minus 4 over x squared minus 9. Okay? Then if I cross multiply, I really have x minus 4 equals 0. So you know what this really comes out to be? You're actually doing this one, that you're putting the numerator equal to 0 is what ends up happening. Because when you put a y in and you cross multiply, we've already put this in the denominator, said, okay, where doesn't it exist? So I've already taken care of this, but when I cross multiply, I have to put this, add 4 to both sides, I have x equals 4. Now here's the thing. That's right, but it's a number. So it's a point on the graph. So we write it as 4, 0. Do not leave it as x equals 4. These are actual lines. So that's fine with these, but here I want you to tell me, oh, this crosses at the point 4, 0. Okay? Now the y-intercept, it says, oh, I had to put my x as 0 to see where it crosses the y-axis. So I actually take my function right here, and I'm going to say, okay, my y is going to equal 0 minus 4 over 0 squared minus 9. So y equals 4 ninths. So this must cross at this point 0, 4 ninths. Okay? Now I hope you graph this. I have now done all the work to show you this. I actually graphed this as well. I always put the grid in. I kind of learned this, so this is what it looks like. So let's just see if everything works. We said that 3 and negative 3. So once you're at the bottom, do a little sketch. So at 3 and negative 3, I have vertical asymptote. So do a nice big xy axis. I left you a lot of space. So at 3 and negative 3, I have a vertical asymptote. Look what happens to my graph. It kind of breaks into pieces, doesn't it? Okay? I also said y equals 0 is my horizontal. And look, doesn't it look like my end behavior of the two tails isn't it approaching 0 on both sides there? Isn't it getting closer and closer to the x-axis? So that's right. My x-intercept is 4, 0. So I'm like 1, 2, 3, 4. 1, 2, 3. Yep, it does look like that points on the graph. Again, yes, it's an asymptote. Yes, it approaches that on the tails. But did you notice how I crossed real quick there? Got a little bit of a shock. I actually hit it, but it's getting closer to 0, and it's not going to touch it later on, but it does cross really quickly there. So there's that point. And then at 0, 4 ninths, this looks like it's a little less. It looks like that's my y-intercept. So you just justified a really nice sketch of this, even though I know you can graph it and look at it. Okay? You just justified all that with this work for rational functions. Questions? Okay, let's try another one. So let me erase all this stuff. Okay. The next one. Okay. So let's get this set up. I always do vertical asymptote, horizontal asymptote, X-intercept, Y-intercept. And when I put you on that, I'm going to ask you to do that. I'll even set up the table for you. I don't care. But you need to know the 4 things that we're looking at. Vertical asymptote, just for practice, the denominator becomes 0. This is my 3 rules, numerator and denominator. X-intercept is a number 0, which ends up being my numerator I'm really putting equal to 0. And my Y-intercept is 0. I would suggest that you do that for a while to get practicing this, okay? Okay, let's try this. Vertical asymptote, what do? Denominator, so I'm going to do x minus 9 equals 0, x equals 9, so it looks like I do have a vertical asymptote at x equals 9, so it goes up and down at x equals 9. Okay, horizontal asymptote. I take the highest powers at the top and bottom, so there they are, x squared over x. So that's one of the 3 rules. What is a horizontal asymptote if the x power is higher in the numerator than denominator? What? There is none. So that is the work you showed. That's the rule. I did it, and like that, I memorized that if the power is higher in the numerator than the denominator, then there isn't one. And I kind of memorized this, that it kind of goes up inside of it. I mean that this power, you can actually, it kind of disappears. I don't know how else you're going to memorize it, but that's what I would memorize. X-intercept is a number 0, so I say 0 equals x squared minus 4 over x minus 9. Cross multiply, you end up with x squared minus 4 equals 0. X plus 2, x minus 2 equals 0. Big T. And I'm modeling to you exactly how I want you to do it. Notice I'm not skipping steps. And notice, and that's one of the things I'm going to tell you with calculus. I always get somebody who's probably smarter than me, who does things a lot faster, and they do it in their head really quick. And so sometimes I always get somebody that loses all these little tiny points just because they're rushing or they don't think they need to show it. And then they get angry at me, and then after a while I go, show all your work, and then they realize that it's for their own good to help them. So I'm warning you now, make sure you show me how you're doing this. Just don't go to here. Say that's what it is. I want to see your algebra, okay? Y-intercept, I'm going to put a 0 in there. Oh, by the way, here I've got to write it as -2, 0. These are points. Please make sure you write them that way. So that means it crosses the x-axis in 2 different places. And remember, you don't have to have all of these. Sometimes you only have a couple. My y-intercept is I put 0 in for x, so I say y equals 0 squared minus 4 over 0 minus 9. So y equals 4/9. So this crosses at 0 4/9, which sounds kind of familiar, but I wanted to show you don't always have to have everything. Now go ahead and graph it, do a nice big sketch on the bottom, and see, does that what it looks like? Does it do what it says it's doing? All right. So I graphed it. So what do you think? See? I actually went from -20 to 20 just so I can see the y equals 9. So right here is my x equals 9. So it must get closer and closer to it as it goes down. I see there's no horizontal. I see where it crosses at -2, 0, 2, 0. So if I ever ask you to do this, I'll want to see. So it does cross at those 2 points, and it does look like it's crossing at 0 4/9. So it's like we found all of that, so that you can kind of do a sketch. All right, I'm going to skip 4. So you can practice 3 if you want, but I'm going to skip 4 to do 4. So this is not homework, because I have book work for you, but I still, if you need to practice it, it's here. I have all the solutions up, so you can check. Just like I did for your trig lab, I put the trig lab stuff up, even though I didn't do it for homework, so you can practice it for today. So let's practice the first one. So here we go. Again, denominator equals 0. What are the 3 rules? Number 0. Or my numerator equals 0. 0. Again, I don't care on the quiz if you graph it. I don't, as long as all your justifications match your sketch. So I'm going to take the denominator, put it equal to 0, so I have x squared minus 6x plus 5 equals 0. And then I factor that. So this is, I want to make sure you're comfortable with that. Is it factorable? Well, let's see if it is. What could I factor that as? X minus 1, x minus 5, x minus 1 equals 0, x minus 5 equals 0. 1 is 1 asymptote. Sometimes you have 2, sometimes you have 1, sometimes you have none. Alright, so I know there's asymptotes there. Now, I picked this one on purpose because I have to do the highest power in the numerator and the highest power in the denominator. So I want to show you that's my highest power. So I have a negative x squared over x squared, okay? The sign goes with it. If you do this and yours doesn't match your picture, you go, oh, yeah, that's right. Then just put this backwards. So what is the horizontal asymptote? This is one of the 3 rules. If your powers match, what do you do? equals leading coefficient. So what's the leading coefficient from the both of these? Isn't there a 1 and a 1? So it's negative 1 over 1. So you can almost like cancel that out. So I know y equals negative 1 is going to be my horizontal asymptote. So if the powers are the same. So for example, just to show you, if I have negative 3x squared over 2x squared, those would cancel out. It'd be y equals negative 3 halves. It's whatever your leading coefficients are. These just happen to be 1. So I just want you guys to see that. So y equals negative 1 is my horizontal asymptote. So I have 2 vertical and a horizontal. So it's almost like you can start seeing where it boxes your function in, and it can only go in certain places, right? X-intercept is really my numerator equal to 0. So I'm going to say 0 equals 4x minus x squared over x squared minus 6x plus 5. I'm going to cross multiply, so I have 4x minus x squared equals 0. Factor out of x, so I have 4 minus x equals 0. Big T, x is 0. 4 minus x equals 0. So x is going to be 4. These are my 2 x points, but since I want actual points, this graph crosses at 0, 0, and 4, 0. Y-intercept, I put 0 in for x's, so y equals 4 times 0 minus 0 squared over 0 squared minus 6 times 0 plus 5. So you have y equals 0 over 5 or 0. And I'm like, wait a minute, I already have that as an x-intercept, but isn't it also a y-intercept without margin? Okay. So now I know all that information, all right? I graphed it. So when I look at my graph, I have it here. So this is what it looks like. So when I look at this one right here, I see, all right, what are the asymptotes on this one? I didn't erase from the last one. So this one says it crosses at 5, x equals 5 and at 1. There's 1. Here's 5, x equals 5. So see how it kind of boxes it in? And then you said y equals negative 1 is another one. See how it kind of crosses here quickly, but if your end behavior here, it's approaching negative 1. So your horizontal asymptote is really what your end behavior is of your function. It's approaching negative 1 here and here, even though it crossed it really quickly here. Okay? The other points I had were 0, 0. Yep, that's on my graph. And I had 4, 0. Yep, that's on my graph. And that was my y-intercept. This doesn't even cross the x or y. So it's like it shows you kind of, it justifies everything that you're doing. Right? Now, that's if I give you a graph. If I give you the function. There's going to be some times where I give you the picture and you got to tell me the formula. So I'm only going to do this one time. There's an extra one here for you to practice. There's 2 of them here. I promise if I put this on a quiz, it won't be as complicated. I promise. It'll be much easier. Because I want to know if you do it by yourself, right? So let's look at next to the last one. So here's 2 graphs. Actually, in hindsight, I kind of wish I put the grid on here. So I promise you also that I will get the asymptotes on here. So this graph is nice. This graphic calculator is nice, but it doesn't show the asymptotes. You know, there is some, but you can't see them. So I promise you if I put this on quiz, I will put them on. So here's one of them. So x equals 2 is one of the asymptotes. I'm telling you, I'm not trying to trick you. X equals negative 1 is another one. So they're not part of the graph, but it's there. I'm not going to dot it and make it look messy. And then I got y equals negative 1 is another one. Okay? So in order for you to do this, you're going to do the same thing, but you're going to work backwards and say, I wonder what this formula is going to be, or this equation. So the first thing I'm going to do is set it up. Y equals, and it's going to be a big fraction. I know it is, so I'm going to do the work over here. Actually, I'm going to do it below it. So I'm going to do the work here. So I have vertical asymptote, horizontal asymptote, x-intercept, and y-intercept. Okay? You can write down what they all mean if you need to, but I do this. go backwards. So let's put down our x vertical asymptotes are x equals -1 and x equals 2. So I'm going to throw that there. There's a horizontal asymptote of y equals -1. So I'm going to throw that there. My x-intercept, it looks like it's crossing at like 1, 2, 3, 0. So it looks like it's crossing at 3, 0. And the other one looks like at -1, 0. So this is when x was 3. I'm going backwards. And x equals -1. So I've got that already. And the y-intercept, it looks like it's crossing down here at -3. So I think that's 0, -3. Okay. So I'm putting in what I can see. And then we're going to go backwards and put them back into this to see what could the function be. Ready? Everybody good? Yes. Yes, it is. Sorry. Yes, you're right. Thank you, hon. -2, 0. Yes. Thank you for that. Thank you for that. Yes, because I would have gone and said, oh crap, I did that wrong. Okay, thank you, hon. Because you're right, it's x equals -1. Right. So let's do this. Vertical asymptote. Now, before it was x equals -1 and 2. What was it before? Think of the parentheses that we did the big T. Weren't they opposite signs in the parentheses? So wouldn't this be x plus 1, x minus 2, right? And if I multiply that out, don't I get what? X squared minus x minus 2. So I'm thinking, remember, this is my denominator equals 0, right? So I'm thinking this could be my denominator. So I'm going to put up here x squared. We're going to check all this out. X squared minus x minus 2. So we're putting that there. I think that might be the denominator. Okay? Yes. Question? Okay. All right. The horizontal asymptote, I'm going to wait. It's kind of, so I did this already. I'm going to kind of do, because wasn't this my denominator equals 0? I'm now going to do this one because this actually comes out as my numerator we put equal to 0. So I'm thinking I can check it with that and with this when I'm done. So if I take it, if it was 3 and -1, what was it before that? Oh, -2, thank you. If it was 3 and -2, what was it before that? X minus 3, x plus 2. So this is x minus 3, x plus 2. And then if I multiply that out, what do I get? X squared, go on. X squared minus x minus 6. So, and then I put that up here. Okay? So now, let's kind of check it. So I did this one here. Check it with the horizontal asymptote. So, what's the rule? It's a numerator over denominator. And I do look at the two highest powers, and I have an x squared over an x squared. So if I circle them and cross them off, what would I get here for a horizontal asymptote for this? Y equals 1, right? I need a y equals -1, right? So how about, this is why I won't make it as confusing. How about if I just switch all the signs in the numerator, because I can do that, we'll see if that works. So if I switch this to a negative, a positive, and positive, would I now get -1? Okay? That doesn't affect your roots at all, guys. It doesn't affect the actual factoring. I just switched all the signs because it's equal to 0. So I'm thinking, okay, so now this works. I now have a negative x squared over x squared. This cancels out. I have the -1. I do that. Okay? So I'm thinking this is my formula right here. Let's last check. I have to have the point 0, -3. So if I put the zeros in all these spots, do I get a -3? No. So this works. So if I graph this, I should get something like this, right? If I did it right, so let's look. I did graph it because I'm a friendly girl like that. So let's pull and look at it. And it comes out. Okay, so you can go backwards. You can go backwards. I know there's another one. This is not coming. But if this really kind of messes you up, try doing it. Try playing around, especially if you have the graphing calculator at home or if you use Decimals to see, can I get this to work out? These are rational functions. Now, to remind you guys, I have now completed the modeling with exponents and power functions. I did that on Friday. You need to do that. I did a couple problems. Make sure you know how to do that. I also did the polynomial formulas lab. Those are all up there. These should be done, or at least you've done what I did in class, so that you're comfortable with all of these. All right? Because when I do the quiz, I'm going to quiz you on all of these. So I haven't given you any bookwork on this, so if you look at this, please, you're going to be doing it here. Let me come here. Oops. It's right here. This is section 1.6, the last of the pre-calculus is there. So this kind of does at all three things. It does power, polynomial, and rational function. That's your homework, okay? Questions? No video, just your homework. Questions on this? Yes? No? Okay, so I'm going to stop